And because this is like an AI event, this is a favorite question that I like to ask. Who's used ChatGPT before? Pretty much everybody is what I expect. But something I'm curious about is like the frequency of how much people are using these like LLM systems. So raise your hand if you use it like at least once a week. Some LLM systems. Okay, once a week. I'd say it's like 30% of people. Okay, how about once a day? I feel like I got more people this time. So that's a little over half. How about like every hour? Who's using ChatGPT right now? Okay, we still even got a few people. Okay. And one last question is for people who are like looking for jobs in the AI space. Anybody hiring? Okay, we got a few people hiring. So if anybody is looking for jobs in the AI space, work out. Okay, that'll be a long appreciate. So I'm Alex. I'm going to be talking about measuring and benchmarking LLMs. A little bit about me. My day job, I work at.
It's like it's not quite sharing.
Whoops. Let me present those guys. Whoopsie. Entire screen. That's it. Hold on.
Yeah, just turn that on.
See. Are you not used to Mac at all?
What's
Yeah,
that?
I'm not. Appreciate it.
It's the AI. And a benchmark.
I'm going to talk about measuring and benchmarking LLMs.
What did you say? You said that you were working somewhere and you stopped. Where are you working?
For my day job, I work as an ML engineer, a company called Mir. Doing a lot of ML engineering work. I get more specific later. I like to classify myself a little bit as like a wannabe researcher and solopreneur. I do a lot of like blog posts trying to solve niche little math problems, and I run a few microsasses on the side. Some like technical subjects that I really love are infrastructure, machine learning, and cryptography. Talk to me about elliptic curves and isogenies. I will be your best friend. But I really love math, and kind of like outside of tech, I love like juggling and fidget toys. If you see me walking around, I'll probably have like a fidget toy in my hand. So the outline for this talk, and I'm going to go a little fast, I know we're eating up on time. The main outline I want to talk about in this presentation is what are benchmarks and why do we use them, especially with this whole generative AI boom. These specific ones. I'm going to give it like a whole survey of these LLM benchmarking techniques, and towards the end, I'm going to be talking about if you have your own AI agent, AI assistant, or AI system product, some guidelines for how to build your own. benchmark and some things to consider. And some of the goals of this presentation, some of the pieces of knowledge I want to review onto you is one, how the foundational model creators, like the Googles, the Metas, and Anthropic, people who are making these foundational LLMs, how they advertise and compare their models with each other. Next, I also want to talk about the purposes of some of these different benchmarks. When you see some acronym like MMLU, which I will get into, what MMLU is trying to test. And the last thing is I want to get you all interested in measuring model results. So if you have your own prompts, if you want to measure the efficacy of it, I want to get you interested in like getting into the practice of measuring them. Okay, so I want to start like big and say, just what is truth? Now, this is not a philosophy talk. I'm not gonna like spout a bunch of philosophy for the next like 30 minutes at you. This is to genuinely like motivate a point. I bought an epistemology book a couple years ago, and according to this book, there's 4 big categories of truth. First one being correspondence, the relationship between observation and thought. This is very much like a scientific method. We have some observation, we collect some data, make some hypothesis, and try and like confirm the hypothesis with data. There's also coherence. Things that are true relate to other things that are true. Very much like an axiomatic math way of thinking. We have some sort of base underlying principles. We try and extrapolate truth from these base principles. Another is consensus. Things are true because people say so. This is very much like, you can think like Roman Catholic Church and heliocentrism. You can also even think of just like the legal code that we all exist in. And like another last category of truth that I'll talk about is a pragmatism, being pragmatic. Truth is whatever works and is useful. And there are other categories in this book, but these are like the main things I want to talk about. And the main point I want to kind of get across is that truth is extremely messy. All of us like use all 4 of these and more different mismatches of different definitions of truth to try and ground us. And my sort of hot take is humans need truth to make decisions. We all rely on the sun rising every day to help us make decisions about how we're going to spend our morning, and many other truths that we all take like for granted implicitly. And AI systems are starting to more and more rule our world and rule our lives and are sort of the ground truth. For a lot of us, we have a whole now generation of kids growing up with this magical brain in a box that they can talk to, that they believe is knows everything and knows how to reason about everything. There's like this concept in transhumanism called the exocortex. The idea of like we're sort of exporting a lot of our thinking and a lot of our knowledge to some other machine entity. And I feel a lot comfortable if these systems, and I'm sure a lot of you would feel the same way, that these systems are telling us the right things. Because if AI is giving us like truthy outputs, then we're going to start to make very garbage decisions. We should try grounding ourselves in reality somehow. So, kind of like the next immediate follow-up question is, how do we actually measure the knowledge of the truth, *TM, in our AI systems? And the standard that the industry has pretty much come to is benchmarks, the absolute necessary evil. So I'm gonna actually go to the next one. Yeah, so specifically I'm gonna be talking about LLMs, because that is pretty much the proto-AGI that all of us use like day to day. So all the big, this is just a mishmash of Meta, Google, OpenAI, and Anthropic. They are self-reported benchmarks. And we're sort of given this barrage of different benchmarks, and someone was saying, oh look, we got this score on MMLU, we got this score on HelloSwag. How are we supposed to like interpret that? If we get like, if one model is like 5% better on HelloSwag than another, does that really like matter? Should I care? Short answer is, doesn't really matter. I'll be honest. So we'll get into that. The thing is, we're given this huge barrage, and who knows, there are going to be new models that are going to be coming out probably tomorrow or next week that are going to report some numbers in these benchmarks. I kind of want to talk about specifically about some of the things that people don't talk about with respect to LLM benchmarks. One is that there's an absolute ton of them. There's no way that we're going to all know like every single LLM benchmark, but there's a lot of repeats that show up in these benchmarks from these big creators. So we're going to talk about those. And some of the interesting things are the devil is in the implementation details. No, I highly doubt, unless all of the big foundational model creators are talking with each other, they're all not implementing apples to apples comparisons, same prompt, same temperature, same other like inference parameters with respect to these benchmarks. They're all doing them slightly different. So it's very hard to get like an apples to apples comparison. Another one is all of them are reductive. An example is like standardized tests is like kind of an analogy I like to think about. Like, does IQ really measure intelligence? Does the SAT really measure literacy? Maybe it definitely has something. And kind of the big two last points is that some of these are useful, but most of them are just a marketing stunt to get you to use their model. Gemini reports, or sorry, some other foundational model like reports like, oh wow, we got like a 95% accuracy on MMLU. This is essentially used as marketing material to get you to use their model. Just want to state that. So, but we're going to talk about them anyway, just so you can understand how you're getting like marketed to, just so you understand a little bit about what these companies are self-reporting. So I'm going to go through like the top 3, top 4 benchmark. There's a lot of them, so I don't have enough time to go through all of them, but go to the big ones. So the first category that a lot of them report is general knowledge, and the big one, big daddy is MMLU. Stands for Massive Multitask Language Understanding. It's a couple years old, I think from 2021. It's from UC Berkeley, and it's basically a large multiple choice exam. It's 14,000 questions in the test split, and it covers like a wide variety of topics. Some of them, like it's claimed general knowledge, but some of these questions are pretty difficult. Sometimes they're like pretty specialized knowledge, like from abstract algebra, medicine, geography, a lot of stuff in there. And I kind of thought it was like this would be a fun exercise. I'm going to take a sample. This is a sample from MMLU in the nutrition category. The question, this one question is, which one of these organs has the lowest energy expenditure per unit of body mass? Big thing.
Right.
I'm kind of curious. I'm going to see if I can do knowledge, wisdom of the crowd. See if we all can get a point here. Okay. Raise your hand if you think it's A. Great. Okay, we got a few. Again, the lowest expenditure. All right, raise your hand if you think it's B, kidney. Okay, got another lift your hands. How about the liver? Ooh, raise your hands. And lastly, skeletal muscle. Okay, I think that's like the most hands, and you were actually right. This is the crowd. For the day. We got this one question. I don't know about you. Only like 13,999 to go. But the point is, I just want to give you a feel for like what MMLU is. It's basically this times 14,000. And how you actually benchmark against this model, you develop your system of prompts, chain of thought, or whatever, and you just have the LLM output like A, B, C, or D, compare against it, repeat against the whole data set, and you get a percentage. Percentage correct. No curve on this test. Okay, the main things I want to talk about though are like the problems with a lot of these metrics, just so people can contextualize these benchmarks a little bit better. One thing is like there's a lot of errors in these answers. I should have included an example in some of these slides, but this has caused like a bunch of different MMLU variations to come off, like MMLU fixed, MMLU plus, and other varieties. Some of these problems are miscategorized. So like, example, that problem with nutrition, like does that belong in like maybe physiology or medicine instead of nutrition? So it's a little bit ambiguous. If a model gets like 90% on nutrition, is it a nutrition or does it know actually a lot about like physiology? That was an ambiguity there. And again, like a big problem I think is like the clarity of the question and the answer can sometimes be pretty confusing. Okay, I'm gonna keep going. One also interesting problem, this is with most of these benchmarks, is intentionally or unintentionally, a lot of these benchmarks have been leaked into the training data. So like a result that like I reproduced is if you take MMLU in its original form and run it through a model, I was able to reproduce Meta's accuracy metric. Here, I actually got a little bit better. Score 1 for me in prompting. 3% marks better. But something interesting that you can see in this paper goes into way more detail about perturbations of benchmarks. If you just simply randomly shuffle the questions, you'll actually suddenly get like 5% worse. You would think that, like to us, like it shouldn't make a difference. If you like testing the knowledge of an LLM, it's like isomorphic. Like a benchmark and a shuffled benchmark should be equivalent, but not to the LLM. So this is like a bit of a problem. Are we actually testing general knowledge, or are we actually testing like selection effectively? Another one is specialized knowledge. This is another huge category, and the big one that a lot of these companies report is GPQA. Stands for Google Proof Questions and Answers from NYU, combination with Coherent and Anthropic, and it's designed to test like the limit of human knowledge. You can think of it as like MMLU, like on steroids, kind of like a frontier knowledge. And it was written by people in the top of their fields, primarily in the STEM field. They were tapped. All these researchers went to people in the top of their field and said, "Can you make a question for this benchmark?" Interestingly enough, like I think it's especially like humans who are getting their PhDs or like in the mid-60s, while like general us lowly humans who are not pursuing PhDs and we're getting like infinite time with Google. I think it's like 30 minutes or an hour with Google. We only get like 30% on this benchmark. Yeah, and so the big problem I think with GPQA is not so bad, but it's labeled usually as a reasoning benchmark, which I think is like a misclassification. It should really be just called having specific domain expertise. Next is like programming. How long until the AI like assumes all development jobs? The two main benchmarks that are here that all the big companies report. They either choose MBPP, mostly basic Python problems, or human eval. And basically, this is just a huge 1,000 question Python programming test. And it's meant for like entry-level programming problems. And the way they're tested is you have a model generate some code. Inside of this data set, there are a few assertions, a few tests, and you just check, does the function satisfy the test? But the main problem with MPP and human eval is a lot of the problems are actually under-tested. There's not enough like tests to fully test all the different conditions for the code, and also it's limited scope. A lot of people think that like, oh, if you score really high in MPP, like the AI knows that code. Wow, that's not necessarily entirely true. MPP is like focused more on like freshman level computer science intro to Python programming. So with that's MPP and human eval. So that's more of what it's testing. It's not a general purpose program. It's very limited scope. Another is math. How long to prove the Riemann hypothesis? The two main, one or two of the main benchmarks here are GSM-8K by OpenAI and its translated variation MGSM. And this is basically a huge bunch of word-based math problems. And I actually really like it. I think this one's pretty good. The only one little problem I have with this one, like super tiny, and it kind of applies to all of them, is there's a little bit of final answer bias, meaning that, and this applies to all of them, we only reward like yes or no if you get the answer. We don't reward the actual progression of thought that you went through it, that you went through. Like, so what? The model was able to issue a single token like 7. Like, we don't get actually the line of reasoning there. That's a much harder thing to measure. Keep going. This one is my favorite one, ELO-based benchmarks. There's really only one that exists. If you know, you know. It is Marina. Marina is amazing, in my opinion. It's a vibes-based benchmark. What that means is Ellen Marina was made by a company called Ellensys, where all this benchmark is like chess in a way. So it's given the Hilo benchmark. We can actually do an example. You're given two different generations of two anonymous models. You mark which generation was better, and whoever wins from the human's labeling point of view gets a slightly higher Hilo score. All right, well, we're going to do one actually real quick. I think we have time. I want to do one real quick. Okay, so we have model A and model B on the left. So I'm going to type in, tell me about UPJ and hopefully it'll do. Might take a second or two. And we're going to judge which is better, and we're going to see after we click which one is better. Okay, here we go. Okay, a lot of output. We'll only read the first few sentences here. GP2's in Miami is a monthly gathering for IT professionals focused on Microsoft 365, Azure, and related technologies. Didn't know that. And then there's GP Tuesday is a special event that has taken over various cities around the world, including Miami. It's an event that brings together pit crews and car enthusiasts. Who knew? I didn't know that. Yeah, they're both pretty bad. I'm not gonna lie, but I think like A is closer, so let's just hit A. And we can see that was actually Gemini 1.5 Pro. Funny enough, and this model B was, I don't even know what that was, but sharp game maker. Okay, let me go back to the slides and try to wrap up. A bonus metric I wanted to mention quickly, because I know people doing like translation jobs.
You're a professor in Miami-Dade?
Machine translation is a whole task, and there aren't like official benchmarks that are reported by like the big companies or reported by individual researchers related to machine translation. But it's kind of like a fun fact is the very first paper that introduced transformers, essentially is all you need. They actually used machine translation as like their core measurement of like how successful and how really transformers are. And the big metric that they used was the glue, but there's other metrics like meteor and turf, like translation error rate. Talk about that later. Cool. The last one I want to mention is some honorable mentions. Some other benchmarks that you can look up on your own time is there's multimodal benchmarks. So the big one is like VQA, visual question answering stands for. All it really is a bunch of pictures with like 7 people and it's like how many people are there. And a bunch of different variations of that. Another is abstract thinking, which is like the ARush Channel. This is Francois Cholet's benchmark. Extremely difficult. There's also standardized tests, AGI eval, and there's some more interesting ones related to AI agents called Agent Bench. A few interesting areas of research I would like to see more that I think are worth talking about are synthetic benchmarks. Benchmarks that are generated either programmatically or by other LLMs. Another interesting piece is about token cost. Something that I think isn't talked about as much is using weaker or smaller models and leveraging more tokens to try and get high quality results that you would get with some of the larger models. I think that would be interesting to see, like not only accuracy, but how many tokens are used in achieving that accuracy. And the last one is about continual benchmarks, because I already showed that MMLU has probably been leaked in a lot of the training data for a lot of these models. I think it would be interesting to have like continual benchmarks that are continuously updated with new data, just so models don't have them in the training data. We can sort of continually get like a fresh test of these like foundational models. So now I'll finish off with some guidelines for building your own benchmarks. So a lot of these pieces of advice are similar to what I would give if you were just assembling your own data set or making your own test set for your application. The one biggest thing is like size isn't the most important thing. Size isn't everything. I really don't believe it is. It's about like having diversity in your data set, in your benchmark. Are you testing unique and like appropriate like cases for your specific use case? Second is thinking like a hacker. It's, let me think of how to say this. Like, you might feel that like, oh, when you're adding an entry into your benchmark, that's like a little bit ambiguous. Like, oh, my prompt isn't really gonna understand this, or my agent isn't really gonna understand this. The way I'm phrasing this is gonna be a little bit too ambiguous, but it relates to the problem. That's like, absolutely, you should like put that in your benchmark. Thinking like a hacker means like, what are the edge cases to like break your system? And I think it's like really important to like collect these and like understand the failure modes of your system. So you should really try and think like a hacker and include the niche edge cases in your benchmarks. Next was like growing your benchmark from user feedback. If the user sees something bad as part of your AI system, you should 100% recycle that back into your benchmark and make sure it doesn't happen again. So you know you're always like progressing. And lastly, my favorite is just a vibe check. This is like my absolutely favorite one. You should have some holdout set of like inputs and generation outputs that you see that is not automated, something that you look at personally, something that's just like a human thing, just to get the vibes for your AI agent or your AI system. Does this look like appropriate based on your whole context of the problem? So at the end of the day, it's really like you building whatever AI system or product to make sure that it's appropriate, and vibes I think are extremely like a legitimate way to check. Yeah, I think that's pretty much it. So happy benchmarking.
Yeah, but I'm going to do firstly, this was a great vibe, and I'm going to do a vibe check. How many people like this talk? So I think we have time for one question, and then there's the questions you can have speakers later on as you can have in the breakout sessions.
Thank you for a great presentation. I have a quick question. Is there any way to identify which model generated the output? Like to check distribution or some meta information or some classification, another classification model that will recognize, okay, this is Gemini. And then it will always identify this is Gemini generated text, and it will always click model A or model B.
I have no doubt that somebody's probably made an algorithm to detect, to classify a model based purely on textual output, knowing this model. But it's probably hidden in the metadata of the actual radio thing itself. So you could cheese it yourself. I'm pretty sure Elvis probably has like a set of people that are labeling prior to making the latest model that are part of their API.
Thank you, everybody. Awesome. Again, a huge round of applause. By the way, I'm going to send the video recording of all these talks are getting recorded and live streamed right now. So you'll get a recording of all the talks plus all the pictures right away. You'll do a match of three and you'll get it before you reach home. That's no problem. Awesome. We have our next speaker, Kai. Kai works in a very interesting